All right, AGS1, welcome back. Today we are going to start Mod 5. But it's kind of weird with Mod 5 because 5.1 was really just kind of vocab stuff that really we've already kind of learned. So we're just kind of going to jump into 5.2, which is all about too big or not too big. We're going to be talking about coordinates today and whether or not they work with certain inequalities that are based off of a word problem. So, essential question for the day, how can we determine the best combinations with given constraints? The guiding problem today is all about Carlos and Carlita. They're starting their pet boarding business, so they're going to have a bunch of cats and dogs at their business. They have a budget of $1,280 to start with, and they need to buy pens and dog runs for their cats and dogs. So, important information, cat pens are going to run us $32 a piece, and dog runs are going to run us $80 a piece. Now, Carlos's dad is like, why don't you guys just start with 12 dogs and 12 cats? Have even numbers. Seems totally fine. We need to figure out why this number is too big. First, I think we should define some variables because we're going to be using x's and y's. So let's call x the number of cats pens that we're going to buy and y the number of dog runs. Each cat pen is going to be $32 and each dog run is going to be $80. So if you take the number of cat pens and multiply it by 32 and then add that to the number of dog runs times 80, you will get how much money they're spending. This whole thing needs to be under or equal to $1,280. So this is kind of our master important inequality. We're fresh off of inequalities for Mod 4, so these should be familiar to us. So let's think about Dad's idea. Dad said you should do 12 cats and 12 dogs. So if I multiply 32 times 12, it, of course, is 384. And if I multiply 80 times 12, that, of course, is 960. And this has to be less than or equal to $1,280, the budget. So if you take 960 and add 384, you guys, that 1,344 means that we are over budget. So, because this is not true, 1,344 is not less than or equal to 1,280, that means you can't have 12 cats and 12 dogs. It's a combination that is too big. Bringing it back to the lesson title there. 12 dogs and 12 cats is too big. So, you guys, there's lots of combinations that could work that would be less than 1,280. Like, it doesn't say you have to hit exactly 1,280. Like, they could board one cat and one dog, and that budget certainly would be under 1,280. So, like, 1, the coordinate, is part of this inequality. It makes a true statement that you will get a number less than 1,280. But there's lots of numbers that would work. Like 1, 2, and 2, 1. Those would work. Like small numbers work, and then certain bigger numbers work, and certain ones don't. They're too big. So what I want to do is find the x and y intercept of this inequality, and then figure out what that would mean in the context of the cat-dog problem. So you guys, to remember that to find an x-intercept, you make y 0. So if you want to find x, make y 0. If I throw a goose egg in for y right here, that's going to just cancel out this whole part of the inequality, and we'll just get 32x is equal to 1,280. Oh yeah, I'm using an equal sign here because I just want to figure out, like, if it was just a line and not an inequality, where it would touch the x-axis. So if you take 1,280 and divide it by 32, you get 40. So divvy both sides by 32 to undo the multiplication. X is equal to 40, which means the point 40, 0 is a point that works in the inequality, first of all, and it's where it touches the x-axis. What this means is they could have 40 cats and no dogs. Remember that X's are the cats, Y's are the dogs. If we find the y-intercept, which remember to find a y-intercept, you need to do the opposite and make x 0. So if you put an x of 0 in here, that's going to get rid of that whole part of the equation. And we'll just get 80y is equal to 1280. And then divide 1280 by 80 and get 16. So, oh, sorry, I forgot to show my steps. I'll be good. Divvy both sides by 80. Y is equal to 16, which means that the point 0, 16 is the y-intercept. But this means they could have 0 cats and 16 dogs. So you can think of that as like kind of the maximum amount of cats or maximum amount of dogs they could have would be 16. And then up here, the maximum amount of cats they could have would be 40. But there could be lots of combinations in between that, like less than 40 cats and less than 16 dogs, but have like some sort of mix of the numbers. The next thing I want to do is take our cat-dog inequality and get it into slope-intercept form. Remember that slope-intercept form is y equals mx plus b, where b is your y-intercept and m is your slope. So we need to get y by itself. The first thing we need to do is subtract 32x from both sides. I'm going to put that slightly off to the side because there's no x on the other side to subtract it from. So it's really just going to move. So 80y is less than or equal to negative 32x plus 1280. Now, I could have written that as 1280 minus 32x, but I'm trying to get it into this form mx plus b, so I just put the x part first and the b part second. Now, divide both sides by 80, which means we need to divide this by 80, but also this by 80. So this becomes y is less than or equal to, now negative 32 over 80, if you start to reduce that fraction, like you could change it into, take a 2 out of the top and the bottom, so it's like 16 over 40, but then you can still take a 2 out, so it's like 8 over 20, and then you can take like a 4 something out. You can keep taking 2's out, reduce your fraction. This reduces down to negative 2/5 x, and then 1280 divided by 80 is 16, which we knew from the y-intercept above. So this is slope-intercept form. Just a quick note that this slope means that for every, how do we want to put this? This is rise over run, it's x or y over x, so that means for every 2 dogs you drop, you can have 5 more cats. So if you lose 2 dogs, you can gain 5 cats. But you could also go backwards and say, for every 5 cats you get rid of, you could, not get rid of like that, you guys just, like if they go to happy homes, for every 5 cats that are not at the shelter or boarding place, you could add 2 more dogs. Yeah, remember that this is a rise over run, so this is like going down 2 and to the right 5. Speaking of graphing, we have the equation, or it's not an equation, but it's it's an inequality. Y is less than negative 2/5 x plus 16. That would mean that it crosses at 16. We already know from our work earlier that it's going to hit at 40 on the x-axis. And now this part right here means that there's sort of slope triangles, means you can go down 2 over 5 each time. So you can go down 2 dogs over 5 cats. So down 2 dogs over 5 cats, down 2 dogs over 5 cats. Down 2 dogs over 5 cats. You can keep doing that to get the graph of this. Hey, look, it hit at 40. That's good news. Let's see here. So that's how it would look if it was just y equals negative 2/5 x plus 16. Now, you guys, if you take a number or a coordinate down here somewhere, like let's pick something like 10 cats and 4 dogs. This is the point 10, comma 4, but x's are cats, y's are dogs. So let's see if that works in our master inequality. So we could check 10, comma 4. So that's making the x 10 and the y 4. So y is less than or equal to negative 2/5 times 10. Nope, sorry, I messed up part of it. That means the y should become 4. So we're checking if 4 is less than or equal to negative 2/5 times 10 plus the 16. So 5 goes into 10 twice. That's negative 4 for that. Plus 16, and then you get 4 is less than or equal to 12. So is 4 less than or equal to 12? It is. So it works. So one takeaway here is that I just chose a number on this side of the inequality and it worked. You will find that if you pick any other coordinate on this side that represents a cat-dog combination, it will work in this inequality right here. If you pick a coordinate on the other side, like 12, 12, remember 12, 12 that his dad came up with? Let me see, 12 would be right about here, and 12, well, it's barely over the line, but 12, 12 didn't work, this spot right here. But if I pick, something ridiculous, like, 30 cats and 16 dogs, this point will certainly not work in this inequality. If you plug it in, you will get a false inequality. So you guys will find that stuff on this side does not work, and stuff under it does work. Okay, guys, there's one more problem in the Go formative, but it's very, very similar, where you set up an inequality, call x the number of this and y the number of that, and then you can find some intercepts, things that work, maybe even get it into y equals mx plus b form. That's all I got for you guys.